Today's topic is cooling tunnels and tunnel pasteurizers. So at home, the reason why we heat up our food is because we want to cook it and make them more pleasant and, we make them more, palatable. But in factories, the reason why cooking food, aside from cooking it, the reason why they heat it is to kill off the bacteria, which might cause the food to spoil. And we call that process of heating food up to prevent spoilage, we call that pasteurization. Now, it wouldn't be very intelligent if we would take a pasteurized product that's free of all bacteria and then dump it into a container that's full of bacteria. That wouldn't make any sense. So one way to solve that problem is to put the food into the bottle or the container when it's still hot, and then the heat from the food that you put into there, from the liquid or let's say the apple juice that you put into there, will sterilize the container itself. So now we have sterile juice and we have a sterile container and everything's great. Okay. Another choice is that we don't necessarily put the food in hot. Yes or no, we'll talk about that in a minute. But we're going to pasteurize the food and the container simultaneously once the food is already in there. So we put the food into the container, we seal it up, and then we pasteurize it after that. Now, one way of doing that, excuse me, is like canning. That's not what we're talking about today. But what we're talking about is a different way of doing that. And the idea is, I guess even with canning, this point I'm going to say is true, which is the idea is you get the product and in the container, actually both ways, even if you sterilize it by hot filling, we get the product in the container to stay hot at a certain temperature for a certain amount of time, and that's a sterilization. For example, we might say it has to be 140 degrees for 15 minutes, and that's going to sterilize the product and the container. Depending on the situation, what the temperature and the time, etc. is, that's a detail. Okay, now, how are you going to heat up a container that's full of food, full of some kind of a product? And then how do you keep it hot for long enough to say that we did our however many minutes we need or how much time we need at that temperature? And after we finish it, how do we get the containers that are now boiling hot to be cooled down so we can package them and label them and walk around them in the plant and not have to touch these burning hot containers? Also, what happens if we're dealing with a glass container? How do we cool it down without cracking that glass? So if we just dump cold water onto a boiling hot glass, it's going to crack the glass. So one way to answer all these questions and to deal with all these things is using having the containers go through a tunnel, either a tunnel pasteurizer that heats up the product, or a cooling tunnel which cools the product. Okay, and I'm going to talk about the two of those things. They're very similar. The two of them, they're variations of the same piece of equipment. The halachic status is not the same, but the equipment is the same. Excuse me. So I'm going to talk about those two things: a cooling tunnel and a tunnel pasteurizer. Now, let's first talk about what it is. Okay, so a tunnel, the way the tunnels are, they tend to be very big. So it could be 20 feet wide and 75 feet, 100 feet long. It's long and wide, but the place where the bottles are, often it's bottles, but I keep using that as an example. The bottles in the tunnel or the cans will be just. The whole tunnel is not very tall. It's only tall enough to hold the inside of the tunnel. Might be just tall enough just to hold one bottle with a drop of space above it. What happens is you put a zillion bottles will be on a belt, and they'll be moving through the tunnel slowly, maybe 1 foot a minute. And as they pass through the tunnel, water is pouring down on them as these cans are moving through. Now, in a cooling tunnel, what you do is you're putting the bottles in already hot. So we're not trying to pasteurize. The bottle and the container, the bottle and the product are already pasteurized, so they don't need pasteurization. But it's just very hot. So what we need to do is we need to cool it down. So what we do is as the containers pass through the tunnel, what will happen is the water at the beginning, the first, what they call the first zone of the tunnel, the water will be pretty hot. Okay, maybe just a drop cooler than what the bottle is, or the can is, and then slowly as it moves through, in the second zone it gets cooler, and the third zone even cooler, until let's say the fourth zone, it's completely ambient temperature to cool the can off. So, for example, let's say we have jelly, grape jelly. The jelly is coming in the cans, the bottle, the jars of jelly are coming in at 190 degrees. So the water in the first zone might be just hitting it at 160 degrees. So it's a little bit of a cooling, a little bit cooler, but it's still very hot water. And then as you move along the tunnel, then in the second zone, the water is a little cooler and cooler and cooler until at the end, they're going out at about ambient temperature. They'll leave the tunnel at 100 degrees. Okay. Now the opposite happens in a tunnel pasteurizer. What happens is there the cans are coming in, or the containers are coming in at ambient temperature, and the water in its first zone might be only 100 degrees. So just a drop warmer than they were. But each of the zones keeps getting hotter and hotter to heat it up. Sometimes in a tunnel pasteurizer, the very final zone will actually be a cooling zone. Okay, but by and large, the idea here is to keep making it hotter and hotter as it goes through, to build up temperature and then hold it at that temperature, whatever the temperature they need to have, to consider it to be pasteurized. Now, when this water that's pouring down is very much recycled and reused, but it's not just recycled, it's actually circulated in a pretty intelligent and ingenious way, and that is as follows. Let's talk about tunnel pasteurizer. Okay, so in my tunnel pasteurizer, I'm going to describe it as if the cans are coming from the right side to the left side. They come in on the right and they go through to the left. So zone 1 is in the right side, and zone 4 is all the way on the left side. So that's how the cans are moving from right to left. But the water, so to speak, moves from left to right, which means to say is the water in the fourth zone, that's the all the way to the right, was heated by a heat exchanger. That water, where it came from, we'll get to at the end. But that water got heated by a heat exchanger, and it's pouring down on the cans at 180 degrees in the fourth zone. It pours it down. It's raining down on the cans at 180 degrees, and that's the final heating for the cans. Now, the water that came pouring down on these cans, it came in at 180. By the time it gets to the bottom, after it pours through the cans, it's only 150 degrees. That water that's 150 degrees gets pumped to the third zone. So that's the zone before it. So it comes down on the cans at 150. Now, the cans that are coming in to zone number 3, they're not 150 degrees. They get heated up by the cans. Okay, in the zone 3, the water gets cooled to 120 degrees by heating up those cans. It goes to zone 2, where it pours down 120 degrees. It gets from there, it gets cooled down to 90 degrees, and the 90-degree water is pumped to the first zone, where it drops onto the cans coming in. So the cans coming in are at ambient temperature. Let's say they're 60 degrees, 70 degrees. They get hit by water that's 90 degrees, and that water then cools down. And now the water coming out of the first zone, the water coming out of the first zone, that water gets sent to the heat exchanger, which gets heated and sent back to the fourth zone. Okay, so what's going on here is that the water that's coming in the fourth zone at 180 degrees is leaving the end at what for it is the end, which is the beginning of the tunnel. It's leaving at 75 degrees, and then it gets reheated to be sent back again. So the water is used again and again. The water is being used again and again. Now, of course, a certain amount of the water gets stuck on the cans. The cans leave wet. So a certain amount of water is lost, but by and large, the same water is being used again and again all day long. And that water is only heated once. It's heated once when it gets into the fourth zone, and then it gives up some of its heat into each one of the zones until it gets heated again. Okay, this exact system that I described is used exactly the same way, just in reverse for a cooling tunnel. Where there, the water, the container, let's say, I said in my case before of jelly, the jelly is coming in boiling hot. It gets hit by the hottest water, and then the last zone, the water is the coolest. So the water coming out of the hottest zone, which is the first one, would be sent to a chiller so that it can come back into the fourth zone, which can pour down on it the coldest water, where the can is by that point the bottle has been the coldest. And this cooling tunnels this slow process works very well for, as I mentioned, for glass bottles, because they could break if they hit them with cold water at first. Okay, so that's the way the machine works. Again, it works the same for the tunnel pasteurizer or the cooling tunnel. In both cases, the water goes from zone to zone to zone in the opposite direction of the containers. The containers are either being heated or cooled, while the water is being cooled or heated, the opposite of what's happened to the cans. Okay, now let's think about what the status of these things is. So, as I said, they work the same, but in order to understand the halacha and the halacha difference between them, we have to turn to Siman Kuf Hey, Halacha Gimel, and we see like this. When food is Yatzaledispai, so it's hot, and it's in a Kli Rishon, that's the pot that we cooked in, then time transfers completely between foods or containers and things like that. Makes a difference even if the food, even if there's like cold food goes into this hot pot, everything transfers in a Kli Rishon, which is Yatzaledispai. Even if some of the things that are there end up not being hot. Now, what happens if hot food comes from the Kli Rishon onto a cold food? As a rule, all the transfer that's going to happen is going to be a bli of katei kli, but just a very thin layer of bli is going to happen. Now, sometimes it makes a difference whether the hot food is on top or on the bottom, if the hot food is moving or stationary. Okay, but those are details that are not so important for right now. Okay, more time transfers when in short, more time transfers when the heat is on the bottom or in the stationary position rather than when it's on the top or in the moving position. Okay, now, we understand that whether something is Yatzaledispai or not Yatzaledispai makes a difference. To our mind, we understand that blia happens more easily when something is hot than when it's not hot. But what's the difference if it's in a Kli Rishon or if it was Irui? Like I said, when you pour it, all of a sudden the rules are different. Or if it was in a Kli Sheini, what's the difference if it's the Kli Rishon or not the Kli Rishon? So the answer to that question comes from Pasteurizer, who says that the temperature is exactly the same in the Kli Rishon and the Kli Sheini. It potentially is the same temperature, but the difference is like this. In the Kli Rishon, the walls of the container, the pot itself, the walls of the pot itself maintain or increase the heat of the food. And in a Kli Sheini, it's the opposite. The walls are drawing heat away from the food. They're cooling the food and drawing heat away from them. So it's because of this that in the Kli Sheini, the food is becoming cooler and the walls are drawing heat away from them. That's why time doesn't transfer the same as in the Kli Rishon, where the walls are keeping the temperature or maybe even increasing it. Okay, so that's what Tais says is the difference between the Kli Rishon and the Kli Sheini. Now, understanding that difference in Kli Rishon and Kli Sheini leads to two possible chumras from the general rule that I told you before. The first is, what happens if the walls of the Kli Sheini are somehow heated to such an extent that they don't cool off the product anymore? Okay, that they're not doing that job anymore. Somehow they're so saturated with heat that they don't do that anymore. Then potentially it doesn't have this weak status of being a Kli Sheini, and rather becomes like a Kli Rishon. So the Taz and the Shach seem to be machmir for this. The Chavazas and Pri Gadim are not so excited about it, but there's a possibility that might be true. That if no defanas and makaras, the walls are not cooling it off, then it doesn't have the status of a Kli Sheini anymore. Our second possible chomer is for davar gush, which is what happens is if the food is not in a Kli Rishon anymore, but it's a solid mez, it's a davar gush, and which means is that it holds onto its heat, and the fact that the walls are cooling off don't have such an effect on a davar gush. It has an effect on a liquid, but not so much on a davar gush. So then there's a whole machlokes about that. Rama is mekel about a davar gush. Mishmur says you should be machmir that to treat a davar gush like it's still in a Kli Rishon, even though it's not, even though it's as if it's a Kli Rishon. That's a shach and among a ram shita. So Mishmur says you should be machmir for that shita. Okay, so those are two possible chumras once we understand why Kli Sheini is different than Kli Rishon. Okay, so now let's turn to our tunnel pasteurizer and then to our cooling tunnel. In a tunnel pasteurizer, seemingly, it seems that the time should transfer completely between the product, the container, and the water and the belt. All the different parts here that we have. We have jelly, grape jelly in the jar. We have a jar. We have water pouring onto it, and then a belt that it's sitting on. Now, the water that's pouring on is not a Kli Rishon. Maybe it's Irui Kli Rishon, maybe even less than that. Think about it. The water is pouring from someplace and it's pouring onto this thing. It's not in the Kli Rishon at that point. But the fact is that water is heating up the cans. It's not just holding onto temperature or hot hitting onto cold. No, this water is so hot, or it's being so much of it, however you want to say it, that it takes something that was not Yatzaledispai. It was ambient temperature, and it heats up well over Yatzaledispai. And I mentioned the case before, and we can make it 150, 180 degrees. Okay, so seemingly we have to treat that as a Kli Rishon. It's taking a cold thing and turning it hot. That seems to be that's a Kli Rishon. It's way beyond when I said about a case of not having defanas makaras. It's not just that the defanas are not makaras. Here, the liquid is actually heating the thing up to make it hotter and hotter, exactly which is what happens in a cleavation. So it's therefore assumed that in the tunnel pasteurizer, the water pouring down on the containers becomes treif. And then it transfers time from that water, transfers time from there onto the belt and to other parts of the tunnel. Okay, now at the end, I'm going to say there are going to be some possible reasons to be makel about these cases, but for the overall idea is that in a tunnel pasteurizer, the water is treated as if it's a cleavation here, and therefore blia is transferred completely all the way through from the product to the water to the belt, etc. So in order to use a treif tunnel pasteurizer for kosher, what you have to do is you have to drain all that water. Again, the water keeps getting recycled. So you drain the water out, not use it for 24 hours, and then you want boiling water to be sprayed over the whole system, and the belt needs to be moving, so we kasher all parts of the belt. Now, what's going to happen is there's going to be, when you kasher, there's no containers running through the tunnel pasteurizer. So therefore, since there are no containers, as the water pours down, let's say in the fourth zone, the hottest water pours down in the fourth. So you have water that's roischem pouring down in the fourth zone. It's not going to get cooled. It's going to stay basically at that same temperature. So in the third zone, it'll continue to be at temperature in the second and first. I mean, usually when you have cans running through, the cans are taking so much heat from them that the water cools down. But here, when we're kashering, it should be pretty easy to keep that water at roischem temperatures in all the zones. Again, because the water doesn't cool down. Of course, at the beginning, as the machine heats up, it'll cool down a little bit, but you keep circulating that water, you should not have a problem being able to kasher it. Okay, so we drain the water, let it sit for 24 hours, and then run water through until it's coming out even from the coldest zone, so to speak, which would be the first zone, coming out at the roischem temperatures that you're looking for. Now, that was all a tunnel pasteurizer. Now let's switch to a cooling tunnel. It's really hard to think of time transferring in the cooling tunnel, because think about it. The food that's in the containers was put into those containers. The container wasn't heated in the container. It was poured from from a kettle. You cooked up, let's say the jelly, and you put it into the thing. So the jars that are going into the tunnel are sheini. Now, you could say that the water hitting the jars in the first zone maybe is not defined as makaras, but it's not really so convincing to say that. That's because, remember, the water that's pouring down is colder than the cans are. So if the cans come in at 180, then the water pouring down is going to be 150. Okay, it's not going to be at that point that we're trying to cool, so it's going to be cooler than that. So it's hard to say we're not having defanas makaras when that's actually exactly what's happening. The water is cooling the defanas, which is cooling the product. That's exactly what's happening here. Also, and it's hard to call this a davar gush. It's true that a jar per se is a davar gush, but the food wasn't cooked in there. So the thing that's in there is really just a plain old sheini. That's what it is. It's a sheini. And the sheini is not considered a davar gush. Now, we know, or I mentioned earlier that when you have a sheini, the only amount of time that transfers is just a ketei klipa, just a thin layer's worth of the food. That's the whole blia that happens is a ketei klipa. Well, that means a ketei klipa is the thickness, the thickness of the container. The container is a ketei klipa, so it can't get through the container. Now, there are those who hold that there's a full-time transfer even in the sheini, not like I said beforehand. But in order to do that, in this case, it's not just that it has to transfer in a sheini. What it has to do that is a sheini and go through the walls of the container. Right? It doesn't help that if the walls are treif, no one cares about that. That's going to a person who's buying treif. It has to go through the container into the water to make a difference going further. Now, usually we machmer based on halachas and siman tzadi beis to say the time does transfer through water. But to that, Rosh says, listen, we're being machmer to say time transfers completely in a sheini, which is not the ikra. Then that time, even in a sheini, passes all the way through, and that it should pass through the walls of the container, which itself is a machlokes or a suffix. So therefore, that's considered a big chumrah, and you don't have to replace the water. The water does not become treif in a cooling tunnel, and the male, of course, the whole rest of the tunnel, also the belt, etc., also don't get affected. Now, some people are machmer and they'll drain the water. But to say that even that the belt and the rest of the chamber becomes treif is really hard to justify in a cooling tunnel. Okay, so it's very different than the tunnel pasteurizer, where there seems very clear that it is treif. Now, so at least I mentioned the different studim, the difference between a cooling tunnel and a tunnel pasteurizer, and halachically what the difference between them is. Mitzias wise they're very similar. Now some additional factors that come into play when we're talking about a tunnel pasteurizer, I guess, or even a cooling tunnel, extra reasons to be makel, and that is, until now I keep telling you, we've been assuming that what's in the container was treif. Well, that's the point. It's treif, and therefore we're worried about it. Okay, but in truth, that's not always exactly the what goes on in the tunnel. And that is like this. From a few different angles. Okay, the first is different than that a little bit, which is that the Ramah says in Ar Chaim that we're machmir to say that tam is absorbed into and out of glass. The Mechaber is makel about that. He holds no blias through glass, and even the Ramah says b'makom tzarich you could be soimach that tam doesn't transfer through. So just something to bear in mind that in a lot of the situations, the tunnel pasteurizer will be dealing with a glass jar. And a glass jar has already this in the back of our minds is that, wait a second, it's only a chumrah to say that time transfers in there at all. Now, a second thing is that we generally accept this, not to talk about, we've talked about it other times, and not for today. We generally assumes that if the only thing that's treif in a kli is stam yayin, then blias that goes through from a stam yayin through to the other side of a container are going to be batal. So that means is if the case I keep saying that we have a jar of grape jelly, and the grape jelly is treif, then that the issue of that grape jelly is that it's stam yayin. That the tam of that stam yayin has to pass through the glass jar into the water in the tunnel pasteurizer. That water, the tam would be bottled by the time it gets into the tunnel pasteurizer. So that's another tzad in some situations to be makel. Okay, and similarly, the third thing, similar is that if the thing that's in the container, if it's not treif but it's milchigs, often the milchigs it's not bottled in the food itself. No, of course not. But it's a small enough amount that when it passes through the walls, it's also rebuttal, like I said, by stam yayin. Not always in every case, but there will be situations where these three things that I mentioned will be additional factors to consider about whether the water has to be replaced and the equipment has to be kashered.